Let's try number 4. Let's look at number 4. Number 4 looks a bit complicated. 1.12 dm cube of hydrogen gas H2 and 1.12 dm cube of oxygen gas O2 are mixed together in a closed container at STP. What is the total number of molecules in the container? What is the total mass of the gases in the container? This one sounds interesting because we have a combination of two things. Two things put into container. Okay, first thing is hydrogen gas. Second thing is oxygen gas. And both also same volume, 1.12 dm cube. This is also 1.12 dm cube. Now I need to know the number of mole of hydrogen gas. Let's use a different color, shall we? We use blue to talk about hydrogen gas. What's the number of mole of hydrogen gas? Is it volume over 22.4? Since they mentioned that all these are done in STP condition, so I could just proceed with 1.12 over 22.4. That will give me 0.05 mole. Okay, remember blue is for hydrogen. Let's use red. Red is for oxygen. Okay, number of mole of oxygen. Remember, use actual volume over standard volume. At STP is 22.4. 1.12 over 22.4. You realize that the figure, they are the same, therefore they get the same value. Alright? With this page in mind, I would like you to replay this if you forget. Let's move to the next page. Okay, I would draw the container again. Now I'm giving you a clearer view. This container, you're pouring in hydrogen gas, oxygen gas. The number of mole that you pour in is 0.05 mole. Here is 0.05 mole as well. You're pouring in such amount of mole into the container. Now the question is, what is the total number of molecules in the container? Right? The container will have a lot of this, right? This. There will be a lot of them, but we need to count them one by one. Again, we use blue to talk about this, right? So the number of hydrogen is simply mole times Avogadro's constant, isn't it? So 0.05 times Na. I don't want to write it out, it's quite troublesome. Okay, I'll just calculate with my calculator. You get 3.01 times 10 power 22 hydrogen molecule. Okay, because they ask for molecules. And how about oxygen? I use red. Here, calculation. Total number of oxygen molecule. I'll just use the normal one. I don't have to care about the two atoms inside. I don't have to. So I'll just use 0.05 times Avogadro's constant. Again, I will get the same value. 3.01 times 10 power 22 oxygen molecule. Okay, so you add up together. I'm sure you can do the maths. When you add up together, you will get 6.02 times 10 power 22. Because 3.01 times 10 power 22 plus 3.01 times 10 power 22, you get total. I'll just put a T here. No, I'll just describe this as total. Total in the container would be 6.02 times 10 power 22. Okay, it may look something like this. There are a combination of two things inside. Alright, so you have this one as well as you have this one. Alright, so how about the total mass of the gases in the container? We use the same number of mole, 0.05, remember, 0.05 mole. Now we find the mass. Mass of, let's use hydrogen first. Mass of the hydrogen, remember, mole times molar mass. Remember the mole is 0.05. Remember hydrogen is 2 times 1. Are you able to get 0.1 gram? Yes, of course. Now, let's consider rate. What's the mass of the oxygen molecule? N times molar mass. So 0.05. Oxygen is 16, remember? But there are 2 pieces of oxygen. So we times 2 times 16. So you should be able to get 32 times 0.05. You get 1.6. 1.6 gram. So 1.6 gram along with 0.1 gram. So your total mass would be 1.7 gram. Alright, so that's it, and you can find out more by repeating the video, and if you like it, tell others. Alright, tell your friends, tell your mom, tell your dad, tell your dog, tell your cat. Alright, and most important thing is if you really don't get it, you should repeat the video or come and see me and work it out together. Alright, if possible.